Hey,
Are we making new code for this exists, modifying the code you have been using the past?
okay, yes. The several projects can realize, well, everything will be using the same core code. But there will be noticeable adjustments depending on the code. And something that minimal adjustment can major adjustment. In sense of programming, and I'm not telling that one is easier than the more complicated, but in sense, not in sense of programming, the easiest, not the program, the most close focus for in the current code of the software is one that doesn't. So it will be minimal changes.
Minimal changes from set. Who has maximal changes?
Fred has maximum changes and maybe he is therefore he's not here.
Probably.
Something. Oh, it transfers signal to the computer and it's here silence. So, the one was well, the project based term is one if he does literally introductory step, it will be easier, but there are infinite possibilities of growth. So if you are hungry for more, your project can be easily become more complicated. If you are
Stamps?
Yeah.
Well, Stamps always hungry to learn more.
Girl, my mental health can't take that right now.
if this subject is the spread answer.
I section this statement.
But maybe you'll find it easy. Let's watch. But in the level the work base,
So am I sure?
you have no dynamics. It will be just another stage.
Because is what you, well, I guess, from what I read, which was kind of, I guess, just a skim over the first one, and just seemed like previously, is it literally just code that I run?
Okay.
Until you run the project. If you run the project, you will type that. Maybe it can be done. We can do major part of the project and then we will improve and fine tune it. If you probably start and spare all parts to everyone. For you have the growth of village generation, and we can inherit the food of this prepared this. But it's yes, but but the version of code for and for a pusher will be two-dimensional, right? Because you have to give me the feeling that and even if everything is relatively simple, it brings numerical challenge because potentially longer and important we need more professional than anyone in the past.
Because it's 2D opposed to just 1D.
Number of the points, like if you have hundred of points in one dimension, and another one, then the number of points is 10,000. And then it's longer. So we will inspect together what heritage of similar. For I am missing we discussed it previously, but I think it needs to learn more about which one of the being associated, and associated.
I'm drawing it out.
This is for me, I took it pretty late, also carried from previous years, but they for the for the but the potentials and the work that they were discussing are different. So you don't have guarantee that it can be directly for. But I'm not sure, well, I'll try to cover everyone's project today, but probably we cannot have our meeting to go too long. We do it at 3 minutes forward, but before we can be taken as modification, simplification of the code for the sure, for the achievement, and then we need to do major simplification. I would like answering your questions much more than designing myself with this. Because
But it doesn't apply to the rest.
they look at
I just
it,
not-
you give them like like need time of designing my own species.
Well, I'm just. We're gonna, I think, have to adjust. What specifically we're looking at in terms of what. Like the research that I do and what the project is gonna be done.
Yes, and it is a big gap between what is needed and what is possible. It's like brown man. Brown. Oh, it's okay.
Yeah,
So,
but you can tell it again.
oh, thank you. I'm trying to do it once.
He's sleeping.
Sleeping.
Is he coming?
So, and then the stranger asked, what way you do? That was the key. And I will look into it. Are you sure that you work the keys under the split way? No, but what way you will be here? Because it's much brighter.
Yeah.
So it's mainly principle of science. So
Yeah.
even though maybe for the deep research, you can think doing this certification or more practical under certain. If by some wonder it happens, why our everything work more than perfect, then you can make it right. More questions? Fortunately, so then they discuss.
Is Fred coming?
So, let me invite him to launch my lab and bring up this latest version of the code. And we will do some modifications which will be practically used for Elven or project and for all of us. It will be just a little bit of modification. Well, of course, it will be something useful. Latest work on harmonic oscillator, I believe you can do it on your own without problems. Please confirm it is so for you need.
Go forward
Yes.
Negative.
for Monday.
Yeah. Can you look through what is required or
I haven't checked
When's it due? Friday.
one day. We don't have school. on Friday.
Friday, I think is the is it completion of the painting of the wall for one? So basically, running code for parabola or common oscillator and just recording observation. Or I have a good excuse for the start of the meeting. I want to ask you about the previous homework, not the one that we graded today, but the one we did before. The answer of the majority of the class for the first question about how the momentum is being implemented in the code. I cannot say how wrong. I just, well, maybe it is some new theory that I'm not aware of, but if it was something I never thought myself, or maybe you take different courses, or maybe some from any of it. Can you explain? And so it was some like integral polynomial, like rho to the power, rho 1 divided by rho. Hello, Fred. How are you?
Just connecting his audio. Right. Where do you get all these chocolates?
Amazing.
You have like,
Oh, they show up here.
oh, that's very interesting.
It's a good class. So it's not for a way. Just curious how you guys were asking the question number one. One homework.
Is that the one we typed?
That was one after our presentations.
Yes.
Yeah.
And the formula that most of you wrote for the question number one has no connection to your presentation or to anything you did together. So maybe you were reading the wrong article in Wikipedia or
Probably, yeah. Probably. Or the wrong article.
Was it called?
Huh? It was not.
Oh, this one.
Yes. It looks like special functions from.
Oh,
But it has no relation to momentum. So no justification of the situation.
I'm gonna be honest, I don't remember anything from the past like that.
Maybe you were at a studying session together and you were looking at the same source. Because it-
Yeah.
kind of copy pasted. Hello, friends. Are you doing okay?
Rhetoric.
Join.
No. Oh,
I'm good. I'll
but we don't hear him.
can you guys hear me?
Let's try once again.
That's why this was gaming.
Hello.
Oh, yes, much better. Happy to hear you. So, just listen what we do, and if you have questions about your project, bring them up. So,
Okay. I might just walk over, honestly. I'm only like a few minutes away. I just took a nap and slept in like way too long. Sorry.
That's okay. That's okay. I'm happy for you because it's my dream to take as many naps during the week. So you look forward. Come on back.
All right, but I'll come over for the coffee. So
Okay.
I'll be back in a minute.
Okay. Then we will not drink all of it. So, okay, we need to start somewhere.
Yeah.
Okay,
Fred is coming over.
I have my molecule and the reaction and it.
So, before we're speaking about very abstract models that stay far away from real life. And sometimes we keep speaking about algorithms. But suppose we all graduated from this course, and then someone on our next academic position on the next job asks like, you took this course, can you do a quantum dynamics simulation for, and then give them a molecule and like, what's the rate of charge transfer for rate of reaction? Can you apply the skills from the physical chemistry course? And you said, no, I cannot. I did all the calculations later and find the whole story. So I think the shape was not very so.
Daniel, tell us, it's like, if anybody asks you in the future and you don't know how to do this like really fundamental thing, don't tell anybody that I taught you. I don't want them to know that you were my student. If you don't remember, don't say that I was your teacher.
I'll think about it. So, what is a mole?
It's or more elements.
Mhm. So,
So,
like, if you
yeah.
have two helium atoms floating around you, is it a mole? Yes or no?
It's not totally.
If you like helium is normal gas, it doesn't form moles. So, taking in definition, two atoms floating around the ideal gas, sometimes colliding, sometimes not. Is it a mole?
It's like two like atoms bonded.
Okay. And two atoms bonded to each other. Can we say that a molecule is a letter?
Two different atoms.
Maybe the same H2. H2 is.
Molecule would be the same, a compound has to be.
My brain is just.
So. Ionized. Have positively charged ions and negatively charged electrons. Right? So collection of positively charged ions and negatively charged electrons that somehow like each other and speed in the same area of space. Okay.
Your besties.
Okay, that's so the ions attract electrons. How do we formulate this statement in the language of potential for an electron?
The electron like has a higher potential for like the fact, of course.
So if I have a like original with less model and it will be very not small but very approximate, even not applicable to real life. Then as a factor of academic exercise, if instead of electron in space, we have an electron in the space where we have one proton, right? And we still want to be one dimension. How do we change our potential?
You. No. Just like.
Yes, you can do it.
Change the potential.
Side.
That's it.
Just side like that.
Yeah.
Thank you. I don't even know what I was saying.
Potential.
Sorry.
How do you change?
It's really the question.
I mean, you can answer.
There was proton or an electron in the presence of a proton, and looking at it in dimension of potential.
And you remember. Guys, he tries to hide his ability.
I honestly I have no confidence in my memory. Change it, you shouldn't. I mean, are we assuming that this is in a box? Or like, what's the assumption aside from
You can
just?
start from a free space.
Okay.
And then in this free space, we have a positively charged proton.
And then
how the potential that an electron will experience will be changed. What do you do with, in a free space, it will be zero potential everywhere. What it will be in the point of space where we have frozen protein.
well, that's gonna be like the only place that it will be like,
Yes, the potential should be higher or lower.
than zero, higher. Like, the potential should be higher for the electron to go towards the proton. Or like affect the proton in the presence of free space. That does not seem right.
But
That
it's
is,
even
that's just the issue with it. Oh, okay.
brainstorming session, like exploring possible opportunities.
Okay.
So on the question, that it should be everywhere zero, except in the vicinity of the rotation of the proton. And the question was, in the vicinity of the rotation of the proton, potential should be positive or negative. Some told it should be positive and experience some healing increase. So let's repeat the question.
Oh,
Will it be positive or negative?
Negative, but.
oh, yes, okay.
Okay.
I agree.
Wait.
Because if the proton's positive, it's going to be attracting the negative energy to surround it.
Okay.
It's kind of just the way that I
Okay. So, negative means stable, right? This action principle, I want to weigh in the Polish rather than stable. So people go down. Electron wants to go to its Polish to the proton, so the potential should be lower. Make sense? I would be happy to say that we are done. Unfortunately, we are not, but it is,
Are we close to being done?
well, we overcome the major barrier between abstract mathematical models and real life.
Okay.
Maybe one more.
We're having a productive talk.
Negative. I agree with everyone. Mathematically, how negative? Not the value, but should it be like,
It should be like whatever negative charge of the electron, right?
electron
At least
electron and proton, how do they interact? Which fundamental law of nature, fundamental law?
that should be zero.
How much fraction of the planet?
You taught me how to write this word correctly. Oh,
Not like climate science.
simple.
Then what it is.
Bang.
So, maybe, Fred can say.
Oh,
The Lord and Savior.
Right.
I started Paul.
in free space.
Two charge particles. Discharge Q1 and Q2. Supposedly one is positive and another negative. And they are away from each other by distance r. What is the force between them?
When you just close it.
Q1, Q2. No, there's a constant to consider, but I think it's Q1 times Q2 over R squared.
What is it a named equation?
Oh.
Equation or something.
So do you hear how Fred said that? So the force, the force is 1 over distance squared, right?
Yes.
And Coulombic potential. The potential integral of force. And if the power is r minus 2, after integration becomes r minus. So the potential is 1 over r, where r is distance between electron and proton. Okay, agree? Okay, I think we are done with all fundamental things and the rest are just applications. And I think the microphones are outside. This is just an I inside.
Yeah, I like it. It has drama. Yeah.
Once I was watching like a comedy show where the characters were making jokes how to make a horror video.
Yeah.
And they did an element. Yes. So they showed just a hand, camera, make a pose. Ah. Okay, so so in a free space, it is potentially zero, right? And if we do have F approach H plus, then electron, there should be an attractive potential, right? So the potential V should be 1 over the distance between electron and proton. If it is one dimensional, then 1 over X, absolute value. Okay, with minus. This is correct. And when in about 2 weeks we will be doing hydrogen atoms, we will do 3-dimensional motion, then there one needs to explicitly take into account Coulomb potential. But right now, if you do 1-dimensional potentials, this 1 over r has discontinuity, is minus infinity exactly at this point. And typically we know that all orbitals, only s orbitals can penetrate close to the core. All other orbitals are bypassing, and they do not experience this spike. So there is a chance to replace it by artificial function that doesn't have this negative spike. And if you have a molecule containing or consisting more than 1 ion, then you will just have more than 1 peaks. So every time there is a ion, electron will feel that it has a negative spike. And I'm going to bring up the older version of code, bring in this little things, and see how the wave packet motion is changed. And this should take no more than 10 minutes. And then next thing will be electric field, and then basically Elsa's project will be done.
The previous one that we looked at. Or is this a new code?
Please repeat or rephrase the question.
Looking at it, are we gonna look at a code to make those graphs?
We take our standard code,
Yeah.
VP, blah, 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 and then we modify it a couple of times.
Okay.
Basically, there is a pre-made it's set up. We will just remove a couple of commenting percentages to activate the right thing. Same as we did for the boxes and barriers.
It was,
Frederick, what's from the you got your subs?
from the Horticulture Club. $10.
Okay,
Names
so
are Fred and George. And, Christina.
here's the code where and you maybe rename it COVID or it doesn't right now it doesn't matter. Molecules.
Pick names. You have this.
It's not.
So you all have this code open. Okay,
Can't speak for my. My mom is a chemist. And Melody does.
so in line 44, I observed there is a V test. And then this long expression that we will analyze, and few lines later, I comment any assignments to the variable V, 2%, and instead of I write V equals V test, just promoting this rating into the variable V. So this combination will approximately model a single ion that will attract and well. And parameters here are modified to treat silicon, but one can, by modifying this E, well, and width, one can tune it to approximately represent other elements. Save and run. Something is not ideal. Weird. Now this one is located at 0.0, which is not good. I want to put it somewhere in the middle. Okay. Maybe in your version of the code, it will work right before you. So you see, it's basically very similar to the box, right? And if we launch our electron to be unbound, if it is an ion that has been ionized, and we try to convert this electron that was away, it may capture the electron, or with some probability it may bypass. If we set up, so this exercise is very similar to what we did for the box. So we set it in the middle and we put small enough momentum. Then major part of the electron probability distribution will stay in or around the sign. And as you see, there is vanishing amount of probability departing from the ion, and this looks like a model of how ion and electron form an atom, right? So the electron is trapped at the ion, but it is only a single atom, right? Now, what should we do? And I'm not going to make a tool because it's like evident, right? If you have questions, if you want me to make a tool, just raise hand. I will quickly jump.
I think it's something weird. I don't know if you want to get it or not.
P not make P not zero very close to zero.
This one
You're running.
better, how's that?
Yeah.
You feel refreshed?
I feel like I'm still ready to go to bed.
Okay, do you get this? Sure.
So mine is the bright green that's like this, the dark green that's like this, but then it's a red one that's just like moving. Like this.
Okay,
And it just keeps moving.
okay, at least one was set. It's good.
It's fine.
It's fine.
Okay.
So partial success. Okay. Anytime before we run the code, we can take clear, then otherwise it may inherit some variables from the previous one. So if we want to have, instead of monatomic, we have diatomic or multiple atoms, what do we change? The lines that I wanted to invite you to look at are 47 to 50. So here we accumulate variable VD, and I do not have a speech data. It's just letter V is repeated twice. And D, let's just look how this equation is constructed. We have our independent variable X, and then we do have the index of the ion, and it is offset from equilibrium by the value AZ, which corresponds to interatomic distance. So I'm going to go into line here, and I will reset V equals dV. Say run. We just need to control the close. We've done the videos and then so what do you see? Okay. So it's like a chain molecule consisting of whatever 10 atoms.
Not look like that.
Huh?
Mine looks like a whole mess. Look at this mess.
Oh, that's good.
It is?
Mhm. And you see your red line goes elsewhere, but the good dark green stays. Yeah. Whoever was trying or
Do I get multiple of the views?
huh?
So how do I get the multiple of the views?
Okay, let me repeat. So Did you answer the question by Sam? What did you ask?
I get multiple weeks instead of just the one.
Oh, wait, I'm asking, it's so information that Elva give you successful. Please help me to answer this. You know,
I don't know how to do that.
yes, you were successfully succeeded.
So Sam,
Yeah.
go to line like 62 where it says V equals I test.
Yep.
You have a percent in front of
I
that?
got rid of it.
You got rid of it?
I got rid of it.
Okay, did you delete the percent for V equals VV?
Yes.
Oh, and then you have to go up to P naught, which is like line 9-ish. What do you have that equal to?
0.75.
Change it to almost 0. I still have it equals. It's like 0.01.
Okay,
Yeah,
that's it.
and then click save. And then click run.
And we could run.
Let's see what happens.
Yeah, you have room to-
Maybe let's, let's close all windows. Images. Then, we can close here and we will. Control C not here in command line. Not in okay. Display. Yes. Let me.
Snow day. And we spent like 4 hours not studying for the exam and just talking about the potential snow day. It got to be like hours or something.
Wait, what did she say?
So you didn't, put the person here, but it's the last. So now if anyone has question about multiple ends and can answer as well. But thank you all for teaching. Yes, yes.
One, electrons trying to combine with multiple positive ions.
Yeah, thank you. So the question is, you address it together. You guys do the homework? Yeah. Did anyone hear the question by Patricia? Okay, maybe it's,
I didn't hear it. I was reading.
just ask for.
You want to repeat that fantastic question?
And for the MATLAB image, the output UV is just one particle, one electrons trying to combine with the positive atoms, or are there multiple electrons trying to do that?
That is based on the multiple peaks. That is an assumption. That is not a known fact.
Now she's careful with the two sentences.
We will be testing that assumption at our earliest convenience.
Okay, yeah, thank you. Would you bring the image of the potential discussion? More? Just maybe put the number one. Yes. So, I think Patricia and Sam are on the same page. They do, and I think they have the same thing as is displayed here. Or something very similar. So we in this code, in this modeling, we always have only one element, right? One. Not two. So when one electron has probability to be simultaneously on several atoms, how will you call it as a trained case?
An electron has a probability of multiple atoms, what do we call it? Imaginary, impossible.
No. You guys know it. Especially if you took organic chemistry, you use this concept. So I know that I'm sharing you these questions in this course, but you know all the answers. It's a little shock of unexpected formulation.
So what electron share between multiple atoms? Yes. A radical? Huh? Only one? I'm not sure. Is it a complex? I mean, it's.
You are much chemist. Oh, by answering this, probably which sounds like a positive.
Bond?
Let's prove it.
Okay.
When we all are in different chemistry, you are ahead of people, but I mean, I told you that I know.
Sorry.
So, when you study SPD things,
Yeah.
how do you call them?
Oh, hybridized.
Just what when you do our bow, when you put electrons in the atom, you have like electrons occupying what in a single atom?
Orbital?
Orbit. And if it is single atom, those are orbitals. And single word for all of them, SPDF.
Valence.
If it is one atom, orbitals on atom. Adjective. Orbital.
Like, are you talking about like homo or lipo?
Let's go back. Let's build our building by small bricks in the foundation. So we are speaking about single atom. And it has orbitals. So those orbitals will be
Bill?
okay. You're correct that this is an adjective.
Excited.
Let's suppose we are not scientists. Suppose we are linguists. So
See, but we think like scientists. We can't change our mind.
thank you, Mr. President. It's
Let's just go 11%. I'm- that's fun.
sorry, mom. I really need to answer this question.
Oh, no.
So, as a legal exercise, let's think that we. So, did you have? And there are orbitals that belong to this atom. Yes.
Atomic orbitals.
So, title of the best linguist goes to Alex. Right. So now, if we have electronic states, orbitals in a model, what will be the name of this orbitals?
A telephone?
Wait. Say the question again. Sorry.
So, when we have more than one atom,
Oh, molecular.
Molecular orbitals.
okay? So it is, do you play with them in organic chemistry?
Yes.
Okay, so you know concept. And when one element is distributed over multiple times, it is a molecular orbital. Okay? So let me show you a trick, being maybe not continuous, and if you go a little away from a straight line towards other project, but you guys should enjoy it. And if you have relation to Sam's project, to Fred's project, basically to everyone. So, when this code has ended, I'm going to, no. If anyone wants to leave, it's okay, but I'm going to stay. My program, my wish is not over yet.
Well, I can't leave if you got useful information. I feel like I'd be letting you down. And I already went off.
So, who? Okay. Equals ID M and M3. Oh, Lord. It's not for you, it's for the method. So 1, 4, X, 1. This way. Oops. Bracket. Power 2. So, what? 1.1. You don't worry. Whew. So, Fred will not only see this image but generate. Sam will likely see images like this, and all of us may add this little skill to our repository. And I will add two.
No, I get what you mean. Yeah, I
So-
know, I understand the question. I don't understand the answer.
Let me send this few commands to you by email. And then, so that if you want to repeat. Thank you, I noticed your email, although I haven't read it yet. Lecture, reply to all. Eigenstates. So,
Jesus Christ.
we are not done answering your previous question. if you didn't notice, we are still working on your question. You are the major generator of questions for the class. Huh? Well, since it was initiated by Patricia, I'm going to ask her, but then continue as the about. So what we see on the screen, how we interpret it.
I can see the potential. I noticed that the potential is not starting from the wave, just as kind of starting off. Like, is there ability of getting an electron out there? Oh, I could just say several potential and several wave function or wave packets.
Yes, yes, everything is correct. So, do you hear what Patricia told? Or do you agree with the way how she expressed it? Okay, I admit that it's my, how to say, fault of making these images too undistinguishable. Maybe make it. Okay, which would be dark. Okay, this one of them is darker. So there are 4 lines. One line is most familiar to us, is a potential that electron is experienced. And it corresponds to like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and many more of whatever it is. After more. Now, what are those lines?
Would that be the? So this is a molecule. I was gonna say, yeah, if it's a molecule, it would be the. It's a molecule, I assume it'd be like your. Might be the wrong word, but your kind of like charge concentration around each atom.
Okay,
Okay. And so then that would then affect your probability of the electrons.
okay.
The thing I noticed though is the fact that you have varying, sorry, you have the varying like peaks, but it doesn't correspond to difference in probability, and it should be. They all look like they're about the same. I might be wrong on that, and it might just be insufficient for me to like notice, but those are the same compared to different peaks.
So the maximum appear maximum of probability appear exactly above the minimum of the potential.
Yes,
right?
But I guess maybe this is more of a question, but why would there not be based on the varying like peaks here? Would this not change? Like do you get what I'm asking?
So we have one blue potential and many probability distribution.
Yes.
Exactly.
But with the probability, like, was it not being like narrower or?
What is my potential?
Yes,
Yeah, would you not modify the potential based on?
No.
it starts at 0 on line.
So
This is like.
Sam posed
Yeah,
very
starts at 0.
important aspect, and he basically covered the research project by Brad. So we all,
Congrats, Fred, I just did your entire project.
we all except Fred assume that potential is not changing. First time in 12 years, only one person will consider how potential is changing due to the church. Well, you are his spiritual leader,
I'm the only
and he
one
will
that's,
probably do it.
I'm the only one that's done what I'm doing.
You haven't done, but you are brave enough to.
Right.
So, I don't know if you were following Sam, but let's convert his words into more abstract mathematical formulations. So, let me repeat after Sam and then Sam correct me if I misinterpreted your words.
Okay.
So Sam told that there are potentials and there are several probability distributions that tell where in space electrons can be located, right? Absolutely correct.
That's indeed what I said.
Now, how do we call this probability distribution? They do not change over time. Okay? So we place electron into this probability distribution and it stays there forever. And it deals with your presentation midterm number 1. So in which states electron will stay forever?
Ground state versus like your. Those states about.
Energized states can also be time independent. Which states will change over time? In which states electron stays forever? Like there are wave packets that change over time, and there are states that belong to given potential, to given Hamiltonian.
I want to say something stationary.
Oh, is it stationary?
Okay, stationary state, perfect.
Okay, let's go.
And those states belong to the Hamiltonian, to the potential. They are its own states, and if it's so, it's my own in German, it will be
My own in German.
I don't know.
I was saying, it's like,
the word own in German. You can look for Google dictionary.
Hey Siri, well, what's,
I should know.
what is own in
I
German?
did, I forgot.
Yes. So
On your fault in.
yes,
Packet.
eigenstate. So who gives us eigenstate?
The Germans?
Yes, more specifically in Austria. And what's the name of this Austrian who gave us eigenstates?
Oh my God, why am I blanking on this?
Very close. Yes. So we get eigenstates from
The Schrodinger.
time dependent or time independent.
I'm independent.
Okay. Right?
Yes.
Now you see whose ends connect to each other.
Okay.
Okay, so what do you think this I stands for?
Eigenvalue.
Yeah, so we take Hamiltonian and we look for its eigenstates. Right? So the code itself solves Schrodinger equation time dependent Schrodinger equation. You see where how effect progresses forward in time. But if you need to solve the time independent, we just do this little exercise. And then the first variable will contain this probability distribution, and the second variable, which I unlocked with called V, I need to use different naming, includes energies of eigenstates. And if you see how it is made here, it was
Say.
so we take the column of this matrix U, first column, second column, third column, absolute value squared, right? And we add, bless you. And we add together the energy of the eigenstate. You feel happier?
I haven't been happy in years.
I always was happy.
You make my day better every couple of seasons.
Thank you for being so generous. So Elsa wants to make a comment.
You said that, it's about the eigenstate of the Hamiltonian.
Yes.
What did you say that tells us after we solve for them? That makes sense.
So, by assuming for that we are not scientists but linguists, we came to the terminology of,
Molecular orbitals.
okay, now we came back to eigenstates of Hamiltonian, which corresponds to electron in a potential of several ions. What are those distributions? On one hand, we call them eigenstates of a single electron in this Hamiltonian corresponding to multiple ions. But on the other hand, it corresponds to a molecule and those eigenstates are orbitals. Which orbitals are they?
Molecular.
Yes. So, you get, you have, custom, you get used to see molecular orbitals as a nice three-dimensional picture. But here we work in the one-dimensional grid, therefore your molecular orbitals are one-dimensional. But we make connection. The eigenstates of the Hamiltonian at the same time serve as a molecular orbitals of electron in the mode. Please approve if you like it or if you don't like it.
You say your last sentence one more time.
Why don't you try?
I
Try your best. It's
didn't hear what you said. That's why.
it's think how we establish how Patricia was attracted to come to this class because she doesn't understand what I'm speaking something. So maybe you say it better. So just provide several possible interpretations of this image.
Of that image?
Yes.
Well, I mean, each line represents a molecular orbital.
Yes.
Yeah,
So on one hand, on another, it is eigenstate of Hamiltonian.
yes,
So eigenstate of Hamiltonian, molecular orbital are the same thing.
okay.
Yeah.
All right, makes sense, yeah.
Okay. Did everyone agree with Fred? Or there was someone who is against Fred?
I'm always against Fred.
So what is unclear in his verbal formula? You agree with sentence, you may agree with Fred as a person, but you agree with his
I
verbal.
didn't hear what you said. I was checking to see what it was.
Maybe you can try that. Just tell once again what you see on this figure, and I bet that you may repeat what Fred told.
I mean, just like, do you want me to just repeat what I said? I mean, like, there's peaks, which is what I'm assuming is the charges of the order molecules.
Yes.
Different.
But your analysis can be who serve the foundation for all of us to build a new theory. So on the top of this probability distribution, you call it eigenstate of Hamiltonian.
Yes.
And at the same time, those are electronic orbitals in a mode.
Yes.
So and which orbitals are those?
Well, with this, I'm
No.
almost positive.
One by one. So, any time between what's molecular
And
orbitals
it's-
and eigenstate of Hamiltonian.
It's kind of, I don't know if it's the same thing with this, but I know.
Okay, so you-
Project, which is really similar. It's going through a conjugated system where you have all these like pi orbitals, and it's a like any conjugated polymer, you would already have like full of electrons, so then you shoot an electron into it and it kind of like moves down that conjugated system.
Absolutely.
And
Or,
there's high
do you follow the struggle rate?
Really following that.
Okay, just say yes or no when you get that. So, the eigenstates of the Hamiltonian and molecular orbitals equal sign.
I don't know, I would assume it's just the.
Yes, you can.
You're a follower of Fred as well.
I'll be a follower of Fred.
All right.
Good. Okay. So, now back to the project by Elsa. So, if we need a molecule and an electron,
I mean, I just assume
if we need just
as it's
a molecule and an electron,
it's.
like two different things, two molecules,
Yeah.
or molecules
Probably some.
and electron.
So that, like, it's like that electron. Is, I guess, not like necessarily has to be like, as it's moving along.
When it comes to your
Ones that have effects on that chain. Like how many peaks are on here, like that's how many atoms happen in that chain, I think. That's at least that's kind of what I understand from what he told me about it at the end of the class. Yeah, I guess so. I mean, I guess I guess it's not really like. So like,
Dimitri, do you know any German?
like, because
It will be more ridiculous and sounds like coming.
really like,
In my doctoral defense in German developed the fluid.
you know, pure sigma bond. ion,
That's
pure sigma
incredibly
bond,
impressive.
like a consistent-
What? He did his whole doctoral thesis, like presentation in German without being fluent in German.
Wait, you? How did you do, how did you pull that?
a consistent-
I practiced a lot
Why did you have to do it?
because I did it in Germany.
Maybe it
Oh.
doesn't actually like. Maybe it won't actually travel
Is
like.
Germany really like a big hub of chemistry?
Because it just becomes like.
Say that's not accurate.
Like electron intensity,
Um,
I guess, like this would be modeling, like how it would interact with each. part of that system. But I'm kind of just, most of that's just speculation, to be honest.
Get a little German lesson with the class today.
Okay, so now we do have two modules, and I'm not like it's the Elsa's project, not my own. Therefore, I'm not staying for being absolutely, not staying for being absolutely precise, and maybe for the project one would need to modify the definition of molecules and potential. But there are two groups of ions. And electron, even if it is placed somewhere in between, it will want to localize on either one of them, right? Maybe I'll do one more modification. This one. I changed position of initial position of electron belonging to the one group of atoms that we would assume be the molecule, and then we will look whether it will be oxidized, whether this wave packet will agree to go into the electrode.
X naught is 20 and X bar is 3.5.
So you see, electron is localized on a molecule, and the probability to come to this electrode is almost vanishing. So it has some little probability, but it doesn't want to go there, right?
How do you know why mine does not look like that?
Mm,
So
I'm,
the red line is still just moving back and forth as an upside down.
I can share this version that I'm using right now. It's maybe accumulation of errors, or sometimes my cat walks on a keyboard and accumulates errors. Okay.
Let me get a cat.
So let me just share, it's not a big discovery, I'll just share with everyone this little script so that we save time on
What's your cat's name?
Mickey, like Mickey Mouse.
Okay.
Becky. Oh. I feel like.
Is there a photos here and it will be too long to find the cat. I'll probably avoid it the
Are you
last
trying to
time.
find a picture of him?
Huh?
Are you trying to find a picture?
Yes, but it will take too long because it like several thousands of figures and it's printed the computer.
Yeah.
Maybe it's already closed.
Oh, no. We're still on the Zoom. You're frozen on the Zoom, though. Your face is frozen.
Yes, but at least I sent the code for everyone.
Yes, you did.
So you can type run.
Ooh. Ooh.
I quit for us. It's not appropriate for the class time and it will take too long time. So you see during the dynamics, the electron doesn't quit the molecule, right? But if it is cyclic voltammetry, we want to see how easily electron is transferred from molecule to an electron. And you want to facilitate it by voltage, right?
So is that, it's oxidation or reduction?
Oxidation.
It's
If you
oxidation.
want to remove electron from the molecule, it's oxidation.
So if it goes from molecule to,
Electrode, it will be oxidation.
okay, but if it goes from electrode to the molecule, is that reduction?
Yes.
Okay.
Now, let's do additional things.
So you just need
Interesting.
you open the code base and
No, I can.
So,
click on it.
Um,
Million errors.
if Elsa is ready, I'm going to say something during 20 seconds, which will be the major part of Elsa's project.
Okay,
Ready?
so I'm not
Or
ready.
not yet? Just prepare, calm down, and say when you're ready.
Okay, I think I'm ready.
Okay,
Does it have to do with the line 64?
yes,
Okay.
so plus putting some small number times x. And I did it with a minus. So the meaning of of this minus x, this slope models for them she out due to external field. So it's save and run. So Elsa, what do you see in the picture?
I have to say that as a different name.
But if you look on how I'm running, what do you see in comparison to your previous one? In the potential.
The peaks are a lot taller and it's moving a lot slower.
So let's collectively help Elsa in her research project.
It's planted.
Oh, okay, she helped herself.
Oh, okay.
So
But I'm
what
not sure why it's slanted.
make a guess?
Is it like the slope and so it's the speed at which it goes from the molecule to the electron?
Related, maybe not literally, but yes,
Okay.
correct in speed. You're training the body in the right direction.
I trade the direction.
I don't know, I feel the potential of ice is lower than, the potential of that.
Okay. Any other comments? So let me draw something on the board.
Spread people.
Let's go back to middle school, high school. Physics.
Okay, oh, I didn't do well in high school physics either.
Mm,
I can try them.
And you had these things repeatedly again, again, and again in different classes. So, if you had this equation,
Yeah,
how do you interpret it?
that the work is equal to the integral of force.
Yes, right? And the opposite. Like if it is not work, but one can do the same thing with potential. And the opposite. Maybe there should be minus, and then force minus UdR.
The derivative of U is equal to force.
Derivative of potential is force, right? You all agree. Now let's project this basics from high school to electric field and an electron. So suppose we do have your favorite element of electronic circuit, a capacitor, which is symbolized by this or double layer potential. So if you have one plate with excess of positive charges and one plate with excess of negative charges, where does electric field is directed to? By definition, electric field goes from
Positive and negative.
positive to negative. Okay, I'm fine. It means the will it be changing here, or it will be the same homogeneously the same inside this capacitor if the plates are infinite?
Be the same.
Okay, good. Now, a positive charge placed here will be driven by force from positive to negative, right? It's a meaning of electric field. Now, if we follow this positive charge as we go from one point to another one to another one, and practice this expression. So just field will be the constant. E as function of R is constant. So it's E not. Now, if you move across and we want to find potential or the work in this situation, it is the same. So we do E naught dr from 0 to empty upper variable. So integral of constant is
Oh,
Or X.
yes, and if it is not X but R, then it will be R, right? So it will be E naught R explored at upper and limit. So it will be E. We need to be correct. We need to put U minus E naught X, right? So potential will be equal, potential as function of the position will be minus E naught X. Now let's look into the code. How do you interpret this little how do you interpret the highlighted area?
Well, I have a question. So would you describe, just like basic question? Would you say that E describes the energy of the field in there?
No, it's strength.
The strength of.
Strength of electric field, it is a force applied to charge of value one.
Okay,
Okay.
all right.
Well, just by historically people use letter E and it confuses with energy.
Yeah, I can see how that would happen.
Okay. So
Are we setting a point 001 to email them?
yes,
Okay.
the potential difference between electrodes, it will be E naught times distance between first and last point. So one can convert it into voltage that you apply on your electrochemical apparatus. But but then you need to know the size of your cell. If you work with strength of electric field, then it will be a little more universal, right? So one can formulate electrochemistry in terminology, either in terms of potential difference on your electrodes or just strengths of electric field in the range where molecule is floating. And by varying this constant 0.001, one will model different slope and different driving electric field that will help the molecule, or the electron, to be removed from molecule and go to electron, which means oxidation. So this little line that show up in the last figure show how the probability on the electrode raises with time. And you see that it goes maybe like 3%. What if we redo this numerical experiment and we increase it maybe 5 times bigger? So the question for Elsa's project is how much we need to change the slope to assure that electron is 100% removed from a molecule to the electrode. And then we can make a graph. On x-axis, there will be values of electric field. On the y, there will be percentage of this probability distribution on the electrode at the end of the reaction. So I change it 5 times bigger, and run, and watch. So you see now the slope is much more evident. And you see that it works similar as gravitation. It just drives the probability distribution away from a molecule towards the electrode. And we see it's not, it gives something, there is some probability, but it's not absolute. It's still only some percentage. So even this substantial slope doesn't make all job.
So you want to change the slope so that it's steep enough so that the red function is over the electrode instead of the molecule?
Exactly. And your main result or main preliminary result will be dependence of the percentage on the value of, you see, it's maybe 4% now. So let's be just a second. Let's try maybe 50 times bigger than our original. It will be really crazy.
So you're trying to get that second graph to cross
Right.
and kind of change. Okay.
Now we even do not see the potential, but it should accelerate things substantially. You see, it goes through this void region and then passes towards the electrode. So it's enhanced probability of the oxidation facilitated by electric field.
Also, what do you like manipulate in?
So you can manipulate the concentration of whatever is in your electrolyte solution. You can manipulate the volts that you're reading something to, and so it's like the solvent window.
You like, so I guess I'm wondering, like, by changing E nod, like, what does that like represent?
Okay,
Like,
so, when we just, let me draw something on the board and maybe then we will come to agreement on the details. So I'm going to erase stuff. And draw. So, voltage,
you just be.
Current.
controlling the
and then,
spread against the current.
you do have the,
Change the current that's being asked. No.
That would make sense.
is it what you get inside the potentiometer?
Something like that.
Okay. So, the V is proportional to change of the altitude that we model in the code. And we see how the current, so the current here is the slope of quickly the reactive gets into product. So the slope depends on the value of the altitude, right?
I think so.
And you can tabulate it and maybe not the whole historical curve, but at least a portion of it. Okay,
That's. Can you repeat that? I don't know if I understood it.
changing of the E node, which we went from 0.001 to 0.05, corresponds to going
The slope increasing from there?
giving different voltage.
Okay.
And depending on the voltage, you have different current. At some values of current of voltage, the current will be maximal. Then it will be again smaller, and then you identify like homos and lumos of your molecule, or the oxidized and reduced better. So your numerical experiment of trying different values of altitude would correspond to an attempt to reproduce this shoulder of your cyclic voltammetry curve. Okay,
So each E naught.
Is 1 point on-
Okay.
okay. Okay, so in some, oh, it was not reported in English. So, to my understanding, the elders project is, I wouldn't say done, but all foundations are laid. So basically, you can complete the project on your own within the next 3 weeks. And I'm not declining to offer any help, but if you get an idea, you can just fine tune things.
So Wyatt wants me to run some data on a polymer that he's trying to make. Is that acceptable to put in my presentation?
Absolutely, absolutely. And if you can establish a connection between the polymer that you're studying and this potential of load and potential of the electrode, it would be absolutely perfect.
Okay.
This is a creative part that would make your project exceeding expectations. If it is too complicated, you just do some arbitrary molecule and electrode is arbitrary now. But if you can make this potential as close to real life as possible, would be good.
So to establish connection between the polymer that we're working with and what?
And potential that we are putting here. So this potential should be chosen as something representing your poems.
Okay.
So who is next? Or we are over time. So let's maybe there is no time for detailed discussion, detailed like processing as we in altogether analyze project, but I believe we are close. This foundation will also help to Fred and Sam. So their projects are somehow related to this one dimension formulation. So. I just want to optimize time so that you can invest your weekend. No pressure. No, it's not mandatory, but if you elect, you can invest your weekend time into the projects. And I think I need to forward the email that I sent to Eva to Patricia because her code can be simplified towards your project. And then I need to introduce to everyone the code that is more or less related to Melody. I'll try to squeeze it in a few minutes, maybe share it with the whole class, and then we will be ready to take it into the Monday, right? Are you in rush, counting seconds, or a few minutes are okay?
No, we're not counting seconds.
Thank you.
You said this. Oh. Dimitri, there's a cat shelter in downtown Fargo that I volunteered at for a while until I got too busy this year. There was a cat there once. It was a black cat. His name was Batman, and he had a brain infection at one point, but he's fine now. No, he had a brain infection, so he has a head tilt, a perpetual little head tilt. He was so cute. It's wonderful. And then there's an office cat named Jason who kind of roams, and he's like this big. He's best. I can talk about cats.
At the University of Washington, one of the key volunteers for the shelter at the same time serves as the coordinator of between TAs and undergraduate labs. And she tells like, I have no connection, but before I assign you a lab in a preferred time, would you like to take home this cat? So I will be very quick. I just better explore. Yeah. The webcam.
Whoa. Open.
Wow.
Mr. Robot.
Good show, bro. You know, when I was in high school, I worked at a museum and except the museum was around since '65. And so all of their thousands upon thousands of artifacts were all categorized in physical binders. And it was my job to convert all of those records into computer records. And there was one point when I was in the middle of this project and my boss, the director of the museum, was like, hey, can you switch all of these files over to this other thing? And I was like, no, that's gonna take me hours. So I did some Googling and I learned how to do it by opening up all of the super secret computer stuff. And I did it in like 3 presses of a button.
That's crazy.
Yeah.
I wish I knew how to use stuff. I can't even use Excel.
Well, wait, there's Ava, Fred, Sam, Joe, Sibel, Wyatt, and Spencer. Why are Wyatt and
It
Spencer?
was
names?
just.
Those are from previous years.
Oh, okay.
What are you doing?
Is that when Wyatt did his rotation with you?
But like, what?
No, it was different. She did, but
A student Wyatt?
it did a different way.
Undergraduate Wyatt?
Mhm.
Wyatt Heron.
Yes, probably. Oh,
I'm in other classes.
Oh.
Analytical. And he works at Happy Heritage. Yeah.
Yeah, we went just different bands, different concerts, and stuff, and he was so excited. It was very cute.
I went to the office for like a couple of minutes earlier today to complain with Wyatt and Spencer about the votes last night. Yeah. Like, hillbillies.
I just gotta be home by 9:30.
Yeah, sleep time.
It's sleepy time. And Xavier wanted to go to analytical part, too, thinking might not be able to, yeah, he's like, no, but. Did you have to take analytical?
Yes.
You were saying, how was that? Same pencil?
I don't know. The first, well, not in my second. The first one, no. Because it was like the year after COVID. So,
He was probably in the second one then, because he was a senior last year. He was Seth's only undergrad last year before I joined.
yeah, that. I don't know what the scheduling is like. I just took analytical one in the fall and then two in the spring
Oh,
last
okay.
year.
Oh, you might have been working that.
Same. Maybe, I don't know.
ZANP.
Maybe,
No,
maybe I
that's
recognize.
fine.
You know, he probably was, and I didn't talk to anybody and I talked with Wyatt
Yeah.
at Savella, and that's pretty much it.
Steph.
Zane was the guy that did the cork ring.
Yeah.
stuff? Yeah, okay. Yeah, I prefer to be on the other side of that ring. You know,
No more than you.
Okay, I found the code. I will send it to everyone, and this is what appropriate to use for nowadays. So potentials can be modified, but here is the idea. We take the red thing, promote it to one of the edit states, and then as time passes by, you see it is drilled down because those are dissociated. So it's model how a bond is being broken. As time passes by, the interatomic bond elongates and we go to dissociated regime. But to apply it wisely, one needs to decide which bond is primarily being broken and how the energy depends on this intervening distance. Even if exact reproduction of this thing is not possible, then we need to make the best possible embedded guess. So if you confirm your interest in this, we can go over, not now, details where which parts of the code modify the these potentials, and the code, this code, in some sense, is more challenging than any other codes, or it is more special. And each code is special. Because all other codes do have only one potential in the surface, right? And here there are several. And those different points means that there are different electronic states. So we have at the same time different electronic states and different vibrational effect, different distribution of the probability in space. So bond length is changing and electronic state is changing as well. And it is cool.
Yeah.
But on it videos. So I'm going to what is this? Yes. Projects. Not folder.
and it's gonna be 73 tomorrow back home.
It was Wisconsin, hell.
Yeah.
Where did Wisconsin come from? Is it like, like,
Like,
Is that-
so, I'm not like, I'm like in a. Huh? Oh, yeah, I thought I was like prepared coming up here last year, because like, you know, it gets cold, like we get a lot of snow.
Is
in
it
the
windy
winter.
there? Or no?
It's not the same here, because we have like trees in Wisconsin.
yeah, the
Yeah.
trees don't exist in North Dakota. No.
I'll tell everybody that the only hills in Fargo are made out of snow and garbage.
Like the landfill.
Yeah.
Are we just driving around?
Two pages the most.
Yeah, that's like, it doesn't say. I was driving around on Sunday. I just went north of Fargo. And I didn't have any like specific destination. I was just kind of driving around and I was in this area full of apartments. I was like, it smells weird over here. And what do you know? The source of that bad smell, I was near the water treatment plant.
Suggest, Melody, this code may challenge the power of your computer.
Oh,
Yeah.
There are three files, method code and three files to save them into the same directory. Maybe before the depart, you just try to run, not wait until it is done, but make sure that it doesn't give you errors and only solves the resource. And whoever is find this project related and interested can also try it, but I think it will be a plus if you get there before unknown of the. And you see, it works.
you want me to run all of them? Just one of them.
On method code and others are method files. They all should be saved to the same directory.
I feel like.
Well, did I promise? To share this data forever towards the patrician.
Yes.
Okay, so I have this.
Then you need to push space a couple times so it will go forward. But make sure if you finally run and do things synchronous on my screen.
Oh, so
You need to have the full three files in the same. When we do the last minute before we depart, just making sure that Melody is ready for the weekend. And of course, during the weekend, we need to run working code in that.
Flex. Your gaming computer.
I think my extra monitor adds like some. RAM, yeah.
I'm gonna download RAM, VRAM.
And you see, here it shows how the one did this MMD for 4 times. Easy, but
Really hard.
easy, but not given an immediate error, right?
no, not yet.
No immediate error.
I have,
Usually the errors, at least for me, if I ever get errors, they do show up like after it's done.
There are errors and warning messages. If you write something in red, it doesn't immediately mean that means that it is. If it generates by period, then there's a hey.
Okay.
But
my computer is a little mentally challenged.
Poor girl. She does her best.
Yeah, she's the product of Black Friday, about 5 o'clock in the morning.
Oh, I should get a new, laptop on Black Friday.
I know.
I
hate
honestly-
Black Friday.
Yeah.
It's a lot of-
You like cyber?
Yeah.
I don't think,
Yeah.
I don't think it was, I got any major discount. I am pretty sure this, so I think it's just because it was Black Friday and it was one of the things out on the front. I just assumed that because it was Black Friday, there would be a sale, but I don't know if there actually was for this particular laptop. Which is why I think it's so bad, because it was like $300. So,
So, I don't want to hold you too long. Let's, make the following plan. If, well, if you want to guarantee that it works, you can wait here, or you can send an email if some problems appear at home, but let's, what is you do?
it's done.
They did send
This again.
Evans. Give us
Yeah, but-
forward.